Had lots of people at 7 this morning, which is nice. Because I don't like getting up at 7. But it's good to have a reason. So questions, ODP stuff we did, new ODP we're going to talk about in a minute, PA1 in particular, scripting, paths to happiness. So let me just clarify a few things about Git, because there's lots of room for confusion. But you've got your Linux machine or your laptop or whatever your Unix system is, or maybe your Windows system that you're writing your code on, right? And we've got gitlab.com, which is the Git server out in the cloud. So over here you have a directory. And you always want to do your work in a directory dedicated to that project. PA1 should be in its own directory. Homework 1 should have been in its own directory. PA2 should be in its own directory. Ideally, your ODPs are in their own directories, just because it makes organization easier. But if you're doing anything with Git, your project has to be in its own directory. Okay? Because Git is kind of most naturally used when you've got a project and you want to take more or less everything from that project area and push it over to Git. That's not strictly true. You could live with just your home directory and do everything in there, but it's more easy to get into trouble by doing that. In particular, if you delete a file you didn't mean to delete and so on. So we picture sort of having a separate directory for your project. So for example, PA1. And when you say git init, that creates this little Git repository area inside your directory. It's hidden, okay? It's in this .git subfolder, but it's basically creating a repository within this directory. If you have another directory, say it's homework 1, and you said git init, it creates a little repository area in that directory. This is totally separate from that, okay? Having done git init for homework 1 does not initialize a git area for PA1. Okay, so anytime you create a directory, you've got to say git init inside that directory. If you say git init from your login directory, what happens? In your home directory, you create this little repository area, right? But that's not usable when you're inside PA1. So this is sort of per directory, but it's really per project. And the same thing when you say git remote add origin, right? That's basically associating this directory with something over on GitLab. When you do git remote add in PA1, that associates the PA1 directory with a project over on GitLab. So this git remote add is making the connection to some repository over here in the cloud. And the idea is now this directory and this GitLab repository are basically connected to each other. When you make files in here and you say git add, git commit, git push, it copies those files over to the corresponding repository.
I saw it said a bunch of branches in Git, and we just called them all master, it looks like.
Yeah.
What are branches?
So branches are a mechanism where you could have multiple versions of your project. So let's say you have 15 files in your directory and you want to start making changes to some of these. What you can do is create a new branch, call it, test branch. And I can start making changes in my test branch and I can push those over to GitLab and so on and so forth. And they don't change what's in the master branch, right? So somebody else who's just pushing over to the master and pulling from the master still sees the original files. But I'm doing all the revision keeping and tracking and so on and so forth on this totally new copy, this new branch. And then at some point, if I decide, okay, so these files, I want these 15 files to be part of the master project, I can do a merge. And I can say, take the changes from my branch and put that into the master branch. But it lets you do that development on kind of a parallel universe. And I'd suggest not messing with branches unless you want to learn about branches, right? If you're not trying to learn about branches, there's no need to mess with them. Okay. But if you want to experiment, right, make a test project and play around with it. And I want to talk more about Git at some later date. I want to talk about how to pull things out of the repository on gitlab.com and so on and so forth. But to do what you need to do to be able to submit and be able to make backups, we've got enough Git knowledge as is. But we'll build on that later. All right, so does this make sense? Right, so when you start PA2, my suggestion is do what you did in homework 1. Use makedir to make a directory called PA2. Go into that directory, start with your git init, your git remote add origin, blah, 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 / pa2.git. And then from that point forward, edit your files, git add, git commit, git push. And set me up as a reporter. It's easier to do that in the beginning so you don't have to think about it at the end. And just make sure you're in the PA2 directory when you're working on PA2. And then the Git stuff kind of falls in the background. All right, Git questions? Okay. ODP 408 is posted. I just logged in, man. Does anybody else have this experience with Canvas? Like the first time you log in the day, it lets you do stuff for about 10 minutes and then it asks you to log in again. It's been doing it to me since the quarter started. It must be me. And I log in again and it'll work great the rest of the day. All right, ODP 408. So this is going to be your first C program ODP instead of a shell script. Okay, so that's, and I think most of the ODPs from here on out will be C programs. So this is a program that expects a command line argument, which is supposed to be a real number, and it takes that real number, calculates a square root, prints it out. So it's a square root program. And there's no error checking. You can assume that the command line argument is present, it's a real number, and it's not negative. Okay. And to convert the argument, which is a string, into a double, use the %lf with scanf. Use the square root function to find the square root and print it out with %lf. And to link, you have to use a -lm switch. So I want to go through this on the board right now and show you the code and so on, because again, this is about being able to compile the program and link it in with the math library and stuff like that, more than the code itself. And we're going to talk starting next week, or probably starting tomorrow, we'll talk about command line arguments in C and user inputs in C and scanf and all that sort of stuff. Okay, but I want to just kind of get the mechanics of using the assess program with a C program. So let's write some code for this. So I'm going to call this my square root.c. So you always want stdio.h in the beginning. And we're going to have command line arguments, so we got to do the argc argv business. So we'll do integer main int argc char ** argv. And we're expecting one argument. Okay, so it says everything should be a double. It says this somewhere, yeah, real number double, right here on this line. So we'll have a double number. Okay, and I'm saying you can assume that the argument is present and that it's a valid real number and that it's not negative. So we don't have to do any error checking. So we're going to do the simplest version of scanf, which is just scanf argv bracket 1 %lf and then address of number. Okay, argv bracket 1 is the first command line argument. So if I say my square root 17, argv bracket 1 is a string containing a 1 and a 7 and a null terminator. If I say my square root haha, argv bracket 1 is haha followed by a null terminator. And normally I wouldn't want to do this because if there's no command line argument, this is going to give me a seg fault. All right, normally I'd want to make sure that argv bracket 1 exists. But since we're not doing error checking in this one, because I said you can assume there's an argument, we can just write this scanf statement. Also, we would normally check the return value from scanf to know if it found a real number. Because if I try to scanf haha as a real number, it's not going to succeed. But we're assuming it's a real, so we don't have to check that. Okay, so after we do that, number should be the number that the user specified. And then I said to print it with a format of %lf with a \n. And let's just print the square root of the number. And that's all the program has to do. So basically 2 lines of code. The first line converts the argument into a float, into a double, right, called number. And the second line computes the square root of that and prints it out. And you have to include math.h. Did I say that in here? Yeah, remember to include math.h. Alright, so this should be a good program for the ODP.
Do we need to return anything?
We don't need to return anything. I guess it's going to complain if we don't return anything. It won't complain too loudly, but yeah, let's just return 0. Or you could say void main and not return anything. But void freaks people out sometimes. Alright, so we want to compile this. So gcc-o, the name of my program that I want to be able to run, which I'm just saying my square root, and then the name of the source file. And then -lm, that's this thing over here. Use the -lm switch to link with the math library. Because by default, math isn't included in your compilation. Maybe it is now, I don't know. But, so that tells us we need to use routines from the math library, in particular the square root function. So that gives you an executable program called my square root. And if I say my square root 16, it prints out 4. That's the square root of 16. If I say my square root 2, it prints out the square root of 2. Alright, so that's what your program should do. So assess my square root and then the name of the source code. And submit it for grading, and there's 10 out of 10. Alright, so everybody can do that? Awesomeness. All right, and the next ODP probably won't open until Monday morning. We'll talk about more C programming tomorrow, but I'll leave the next ODP until next week. So this will be your last one this week.
What time is Stick due tomorrow? Due tomorrow, right?
Stick is due at 8 a.m. All right, any questions? All right, let's see if this worked. So on Canvas, if you go to codes, code from lectures, that'll take you to a shared area. So I'll push some code up here once in a while. So there's the code we just typed in, my square root. All right, well, let's continue looking at pseudocode. So you did code yesterday for the average of numbers that the person types in until they enter in a 0, right? So let's try some more pseudocode. So read integers from the user until they enter a 0, and then you want to print the max and the min of their numbers, and not including 0. So if all their numbers are positive, don't count 0 as the minimum, right? That's not a valid number. That's just indicating that they're done entering. So you're going to read numbers from the user, type a number, hit enter, type a number, hit enter, until they type a 0 and hit enter. And then you want to print out the largest and smallest numbers that they typed in. Okay. And we want this as a structure diagram. So something like this. Okay, so something in that style. So no arrays, because we don't know how many things they're going to put in to begin with. So don't just store everything in an array. Try to find the max and min as they're putting in the numbers. No break statements. So try to code a while condition that exits the program, exits the loop properly. And don't write bash code. Well, you can write bash code too. But try to write this as a structure diagram. All right, and if you can work in groups of 2. So you can find someone sitting next to you and work with them if you'd like. Or you can work alone.
No raise, no break statements. What's that structure.
And you can ask questions along the way if you like.
we need to store all the numbers somehow.
You do not want to store them because you don't know how many they're going to be ahead of time.
And we can't use an array, so.
You can't use an array, but you can do this without storing the numbers. But that's one of the trickier parts of it.
So we ask if the number is larger than
Yeah. Okay. So the first thing we need to do is read a number. So get zero, get in, and then we can zero is what we use. First thing I would do is check and see if that number is zero. Put that in the statement. Sorry, can you repeat that? Yeah. The first thing I would do is after we got that number, check and see if that number is zero. Because if that number is zero, yeah, go to the end of the program. So I think I would put all of the rest of it in if statements.
Okay.
Since we can't use break. So if zero.
Yeah, I'm reading it now. Like text zero. That'd be in a while. Oh, I guess.
We could start a while loop on that. We could put read in and the bottom with zero, we can put this in the while. And we have a couple of options we can do.
Yeah, like that one.
Okay.
It's a while.
Okay, so then we start a while. Because that's conditional also because that means if it's all the information, we can so just like ones, zero, we don't have a min or that. So like I said, that's with zero. So then while would be
I mean, should we set a min and max?
yeah, okay, that works, yeah. Set min to zero, so max is zero. So then while n is less than min, or n is greater than max.
Sorry, I realized that. What if the first number of these percent is -1? That's going to be in it.
It doesn't say that they can't use zeros, or negative numbers.
But I'm just saying, like, if the max is 0 and the user's initial input is -1, that's going to be the max number, right?
Yeah, so let's say they put -1 in. -1 would be less than 0.
Right.
And that would replace the new min.
Right.
And the new max would be 0.
But isn't that not right? Because like the user put in -1 as the first number they put in. So that has to be the min and max.
Oh, I see what you're saying. Because there's only one number given.
Right.
It has to set both. Well, if it's a conditional or statement, wow.
So we could say for the first number that the user puts in set
So read
the
n
min
and
max.
set n, max and min to n.
Right.
Yeah, let's do that. Okay. Okay, so now we have used that variable. So now we need to get a new variable that we're going to read this first time.
Right, right.
So then we need to read Sure. Should we put that as a problem already? Because here's what I'm thinking, is in the while loop, we have a check and now that we're going to break the loop.
I think you're right. 'Cause,
Because what we're doing is we're checking if A is greater than or less than 10, or greater than or less than the min or the max.
right.
How do we do with this? Choosing a breaks them. So one thing we just always get out of a while loop that I learned is while I does not equal 0, and then they can just make I equal 0.
Okay.
Because it'll check that. It'll still do anything below that, so that's to get it to the while and then check.
Right, right, right. I like that.
So let's see what that'll do. And we'll just make I just over here. So that's while we can have. So now we can check. Or no, now we need to read. Now we need to read A.
A greater than or set A is max.
Yeah, A equals, or A equals N, right? Or N equals A.
Right, right. No, you're right.
And if you're done with that, go ahead and pass it in. If you want a few more minutes, take a few more minutes, but I'll start looking at the ones that are
And
finished.
then it falls, we don't need any of that. We can just discard A. We don't need to.
But then, don't we have to check for the mins?
I think we should do that in a separate, well, we could do it else there.
Yeah, no, I like the way that's
Are we supposed to check for a valid input?
Oh, no, max.
No, you can assume it's valid.
I think I might do it straight by saying N equals A, which should actually be max equals A.
Yeah, yeah, I caught that.
Okay, cool. Ooh, we probably should have a definition up here that says read A if A equals 0, I equals 1.
Yeah.
Or I equals 0. Yep. Can we just set I equals 1 somewhere?
Just like in a conditional above the, after the read A, but above the, yeah.
That makes sense.
I almost think that if we do it that way, then we can take this out and move it to what the
Sure.
to 1, so this way.
Yeah, right over there. Sure. So the least that we do.
All right, so take another minute and then let me see what you got if you haven't turned it in already. All right, anybody else want to turn in?
Yeah.
All right. Cool. All right, cool. Okay, these look good. I think everybody's actually got it. So I'm just gonna pick out some sort of at random that's sort of show different approaches to doing this. So here's one. So read a number, set the minimum and maximum equal to that number, because if you've only read one number, that is so far the maximum and minimum. And I think everybody keyed in on the idea that you need to keep track of the max min as you're entering numbers. So each time you get a number, ultimately you want to compare it to the max and min to see if those get changed. So start off with the max and min being the number, and then while the number is not 0, if your number is smaller than the minimum, go ahead and set the minimum to the number. If the number is bigger than the maximum, set the maximum equal to the number. And then read the number at the bottom of the loop and go back up to the top of the while loop. And then print the max and the min, and we got a comment on there too, which is awesome. So that looks totally perfect, all right? And that's the effective idea of pretty much all of these solutions I'm seeing. So this one is using a flag, right? So ask the user for n, start off with the max and min equal to n, and then I is being used as a flag. And as long as I is 0, we want to keep looping. So read a number from the user. If it's equal to 0, set the flag to say, let's exit. And don't do anything else. If A is not 0, then compare it to the max, and if it's bigger, set the max, and then compare it to the min, and if it's smaller, set the min. So that's going to be exactly the same effect as this. The bash code is going to look fairly different, right? You've got this extra variable that you're using as a flag. And that's a perfect example of what a flag is all about. It's noting some condition that you want to act on later instead of acting on right now. Now, if I let you use a break statement, you could just say break right here. But since I didn't let you use a break, you're making note of the fact that you want to exit the while loop, and then later on when you come back to the top of the while, it'll kick you out. So that's excellent. All right, so this one started off with min equals positive infinity and max equals negative infinity, right? So that anytime you get a number, it's going to be bigger than negative infinity, your first number is going to become the max. That works sometimes, okay? In Java, we actually have positive infinity and negative infinity as valid doubles. Okay, there's actually a way in that representation, IEEE 754, to code plus and minus infinity, so you can actually do that. That's an alternative to starting off by setting max and min equal to the first number. But you gotta be careful if you do this, right? So I've seen people try to do this with minus 99999. They'll set that as the maximum. Well, that's fine as long as you know that there's never going to be a number smaller than that, right? Because if there is, that will potentially trip things up. Same thing with setting the max and the min to 0. That's okay if you know that all your numbers are going to be bigger than 0, right? But if you can have negative numbers, then they might all end up being less than 0, and you would think that the max was 0, which wasn't actually a number that was entered. So here's another example with a flag called stopped, right? So stopped was actually given a Boolean value, stopped is false, and then we just do this loop while stopped is false. In other words, while we're running. Same thing, and if the input's 0, set the stop flag to true. So that's a nice use of a flag. So this one and a previous one also, right? There was a big if statement. If the input is 0, then we set our flag. Else, we do all of this stuff, right? So that's going to be if, then, else, and then a bunch of stuff in the else. An approach like this is saying read the number n. If n is bigger than the max and n is not 0, set the max. If n is smaller than the min and n is not 0, or if this is the first try, then set the min to n and clear the first flag. So this is using a flag. It's still exiting when the user enters a 0, but inside the logic of the loop, they're noting that this is the first number that's been entered and using that to set the initial max and min. And then the ifs, instead of being an if with all of this being in the else, they're actually checking for the n not 0 in each case. Perfectly fine, right? Going to look very different in bash, or whatever language you code this in, but it's perfectly valid. And looking at this, right, it's pretty easy to see that this is going to work. It's pretty easy to see that this is going to work. If you looked at the raw code, right, with ifs and curly brackets or fees and dones and so on and so forth, it may not be so clear. All right, cool. So suppose you wanted to have the user enter numbers until they put in a 0, and then you want to print out the average of all the numbers that they entered, excluding the largest and smallest numbers. So you want to throw away 2 outliers, the largest and the smallest. And you don't want to save these things in an array. How could you do that? Because if they're not saved in an array, you can't go back and get the numbers after you found the max and the min.
You can do what you just did, keep the min and the max, and then have a running sum, and then subtract the min and the max from the running sum.
Perfect. So once you're done, you can simply subtract the max and the min from your sum and take off 2 from your count, right? So use the code that you wrote yesterday. It keeps track of the running sum and the number of inputs. And then when you're done, just get rid of 2 from the count, take off the largest and smallest, and calculate the average. And that's going to be a lot more efficient than storing all of the entries into an array, going through, finding the max min, and then going through, finding the average and ignoring the max and the min in there. Okay, so is this making sense? I don't know if this will be useful to you or not, but I think it's important that in some way, shape, or form, before you start writing code for something, try to do some kind of development of the algorithm itself. Whether it's written out pseudocode or a structure chart or a flow chart or something else, try to do something like this before you actually start writing C code or writing bash or working in the editor, and see if that reduces the number of the amount of debugging and kind of false starts that you have. All right, we got 3 minutes. One thing I want to talk about in this class, and I'll just start it very briefly here. Are things you can do to make yourself more efficient. So you're developing your code, right? You're generally editing, compiling, and testing. Editing, compiling, and testing. Okay, so I may have mentioned this already, but the up arrow on your keyboard will let you get to previous commands. So I want to VI my file, I can just up arrow to my last VI, and I can go ahead and make some changes. And then I can up arrow to my last GCC, and I can up arrow to my last test. And if that's all you're doing, for me it's going to be always 3 up arrows. Bang, 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 there's my editing. Bang, 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 there's my compile. Bang, 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 there's my test. Okay, that's saving you a lot of time right there. So I tried to compile my program and I made a typo, right? I can type the correct line again, but I can also up arrow to recall my command, and I can go back and I can change that GC to a GCC. Okay, I can hit the back button a bunch of times, but I can also say Control A. Control A almost always means the beginning of the line. Control A and it takes me right there. And now I just go forward 1 and type my C. And it's an undefined reference because I forgot to say -LM. Hit the up arrow, space, -LM. Okay, so if you're editing a line, Control A takes you to the beginning, Control E takes you to the end, and Control arrow moves you a word at a time, which can be useful. So there's things you can do. If you like, you can actually set up a variable that makes the entire command library of VI available to edit a single line. You can go back with B and forward with W, and you can do CW to change word and DW to delete word. You can do all sorts of complex editing if you know VI. I lived with that for about a year and realized that I hated it, so I stopped doing it because I always forgot that that was there. But there's stuff you can do. All right, so that's the end of our time here. So tomorrow we'll review the stick program. We'll talk about PA2, and then I want to spend probably the rest of the time talking about things that we can do to customize our environment in Linux and to be more efficient in doing our work. So we'll go from there.